All right, so on these, the first one, simply PEMDAS, order of operations. We're going to do multiplication, then the subtraction. Same for number 2. They're all negative numbers, so you would add them all together and it would be a negative sign, right? On this one, what property are we looking at? What happened to these guys? Do you remember those?
Is it associative?
Associative is who you associate with. So if we're all in order and you're talking, Josh is talking to me, and then you stop talking to me and you start talking to Isaac, we haven't changed orders. You've just picked who you're associating with. So remember, associative is who you're hanging out with. When you change places, when your dad leaves work and he drives home, or he leaves home and he drives to work, he's commuting. So commutative property of multiplication, when we've actually changed places. We've gone from one place to the next. So that's going to be commutative. Associative, everything has to be in the same line, and you're just deciding who you're hanging out with first. I'm going to talk to you. It's like in church when they say turn to the person and say hi, and then they say turn to the person that you didn't turn to the next time. So it's who you chose to go with first. Okay? For f of x, this is function notation. Function notation is always written f of a variable, f of x. You'll need to know that for the test. That's what function notation is. So it gives us instructions. It means that whatever is in the parentheses is what we're choosing to plug in as the variable number, right? So this f of 2 tells us that the variable needs to be the number 2. So we're going to put 2 wherever we have our variable. So 2 times 2 is 4, plus 6 is 10 on that one. Again, write as a function of x. In this case, so we're writing it as an f of x. If it's going to be a function of x, f function of x, f of x, that means my equation must have the x value, right? So x is going to have to be over here. So we are solving this for y. F of x is another way to write y. Okay? Exact terminology that you need to know. Right, so in this one we would simply solve the equation for y, and then instead of writing y equals negative 2/3 x plus 2, we would write f of x is equal to negative 2/3 x plus 2. Right? Okay. Oh, goodness. Where's my, anyone see the cursor on there? There we go. Okay. So a couple of things for review is that when we were looking at linear equations, remember, so everything from prepared today. Oh, that's last week's science lesson. I'll leave it. Okay, linear equations means we just have a line on a graph. So where the line crosses is called a what? What's that called? Intercept. Perfect. It's called the intercept. So what question do we ask for our different intercepts? When x equals 0, right? So remember now, whenever you are making, giving solutions, you should most likely have a coordinate point. So when x equals 0, I'm going to write 0 for my x. Y equals what is our question that we ask for finding which intercept? When x equals 0, what are we following? The y-intercept. Okay? So then what question do we ask for the x-intercept? When y equals 0, we are finding our x-intercept. Excellent. So knowing what we're looking for, when we had a plane and we had that, we have switched it now and we have x, y, and z. Then we ask for like the z-intercept. We're going to ask when x and y are 0, what is z? That gives us our z-intercept. So remember, we're always asking those questions. When x equals 0, when y equals 0, and that is telling us what we've got going for, okay? So if we have a solution for two different lines, where's the solution point?
Where the lines intersect.
Where the lines intersect, okay? That means that that point is valid for both of the equations, okay? If it is not valid or true for both of them, it is not a solution, okay? Let's see. I just went over functions. So when does a system have no solution?
Parallel.
When they are parallel lines. Correct. When does a system have infinitely many solutions? When it's the exact same line. Excellent. When does a system have only one solution? And what?
The lines are perpendicular.
If they're perpendicular, yeah. Or just when they have any different slope. Right? So as long as if I have y equals x plus 2 and y equals 2x plus 2, these have different slopes. Any two lines that have two different slopes will always have one solution. It will cross one place, somewhere. Okay? So when we're looking at it, that was part of the review this week, is I wanted you to just be able to look at the equations and see what that looks like. When you have two equations, you can simply look at the slope and decide right away how many solutions you're looking for. If they're the exact same equation, it's the exact same line. It's infinitely many. If they have the same slope but different intercepts, that means they're parallel lines. They're never going to meet. If they have two different slopes, somewhere they're going to meet at that point. Okay? If you are working in a 3D plane, how should your answer look? Every single time. It should look like an ordered triplet. Okay? It should look like X, Y, and Z. Versus we've been working in the 2D plane where we just had X and Y, right? When we work in the 3D plane, it should always look like X, Y, and Z. You should have three values for that. All right. Let me see what else. Be sure to know how to graph a system of equations, to graph each equation, both for equals and inequalities, less than or equal to. Remember, if it's less than or greater than, what should your line look like? Dotted or solid? Dotted. If it's equal to?
Solid.
Solid. Okay? When we have it set, we graph it as if it was equal initially, and then we decide if it should be dotted or solid. And the variable that is by itself is the one that we ask ourselves about in regards to graph, in regards to shading, right? So if I have y is less than 2x plus 2, I'm going to have a steep slope through 2. If I pick a point on there, I am going to say y values. Y values are what values? Horizontal or vertical values? Where are y? Horizontal or vertical?
Vertical.
Vertical. So y values, we're looking at vertical values up and down. So my y value is less than, that means I'm going less than that one. If I ended up with one that was x is less than 2, say I had the same 2y plus 2, and somehow we've got that. If my x is the one by itself, I'm looking at x values. So my x values are less than. So if I have my line, I am now looking at horizontal values, x values. So from this point, I would be looking at negative x values. This is negative, this is positive. So we'd say x is less than, and we would be shading that direction. Do you understand how that makes a difference on your shading? That should help you with that. Be able to solve a system according to both substitution and elimination. And graph. Okay. Any questions from homework that anyone had questions over? No? I did post videos over the chapter 3 review over all of the problems and worked them out. And so that's posted on the Google Classroom. If you have any questions about chapter 3 review, I recommend that you go over those. If you did not complete your cumulative review for chapter 3, please do so before the test, and also make sure that you fully understand it for the test. For that, it will be for your benefit. All right? If we don't have any questions,